Hey guys, 1 second. Sorry, I had to clear my throat. So today we're going to be doing the Chapter 8 review questions, some homework problems. First review question that we're going to do is 3. Actually, the ones we're going to do 3, 4, 5, and 6 are the questions we're going to do, and we're not going to do any of the plug and chug because that's just a lot of very basic math and whatnot. So let's do 3 really quickly, and it basically says, which requires more work? Lifting a 10-kilogram load a vertical distance of 2 meters, or lifting a 5-kilogram load a vertical distance of 4 meters? Well, we're looking for work, right? And I encourage you to look at the question in your book because I'm not actually going to write the whole thing here. I'm just going to be solving it. So let's look at the work for the first, well, this is force times distance, right? So let's look at the equation for, or the work that we'd get for lifting the 10-kilogram load. Well, we'd have the 10 kilogram load a vertical distance of 2 meters. Well, 10 times, weight is also considered force. 10 times 2, right? 20. This is for 1, right? And so we have work is equal to 20 for our first system. And for the second load, we have a 5-kilogram load, a vertical distance of 4 meters. 5 by 4 is also equal to 20. Work is equal to 20. Okay, so they're equal. Say neither, say they're equal, right? Let's go to 4. Oh, another way to look at this, you can really quickly, without even doing the math, tell that they're going to be equal because here, this halves, this is divided by 2 to go to 5. But this is multiplied by 2 to go to 4, so the equation balances out. That's how I like to look at it. But okay, 4. It says, how many joules of work are done on an object when a force of 10 newtons pushes it a distance of 10 meters? Come on. Too easy, right? 100 and, yeah, 100, right? 10 times 10 would be 100, and it says how many joules of work, joules being our unit for work, joules. Right, okay, let's go to 5, see if I can conserve space here. Use a different color. 5. How much power is required to do 100 joules of work on an object in a time of 0.5 seconds? How much power is required if the same work is done in 1 second? Okay, so power, we know. Power is equal to work over time, okay? Work done over time interval. So for that first one, it would be, let me look at the numbers, 100 joules of work 100 over 0.5 seconds. Look at the joules of seconds, right? And that equals 200 watts, right? 200 watts of power. The joule seconds combination is watts. And then it says how much power is required if the same work is done in 1 second? 100 watts, right? And then 1 second be 100 watts. Okay, pretty easy. Now we're just going to move on to the last one, number 6. Yeah, this video is pretty fast to compensate for the last 2, which are fairly long. 6. What are the 2 main forms of mechanical energy? Very, very easy, and I'll describe them briefly. Kinetic, and potential. So, we have moving energy, often creates heat. You know, it follows potential energy often. So, and they convert back and forth. So potential energy being stored energy, and by virtue of something's position, by virtue of position, and then good to know, gravitational PE is PE due to height, right? Height. Okay, cool. Now, this video is done. It's a rather quick video. We're moving on to Chapter 9, circular motion. And so I'll see you in the next video.